Well, it looks like we've got pretty much full house, so I'll give just a quick intro. Dylan here should be familiar to most of you guys. He's a graduate of U of I's architecture program and has been working here since being a grad student, has since graduated, and now is kind of our full-time research staff, specializing in daylighting and some energy modeling. So we're happy to have him present today. Couple orders of business. You've got evaluations. Don't forget to fill those out. You've also got raffle tickets. So put your info on the back of that, and we'll drop them into a cup and draw at the end for a couple of fancy light bulbs. Our next presentation is not going to be here because our lab is moving. We are moving to the Water Center just down the street at the end of next month. I think October 29th is our move out day. And 26th. So, oh, cool. October 26th. By November, we'll be over there. Yeah. And our next BSUG is going to be combined with ASHRAE. It's going to be that meeting on November the 13th. And I'll be doing the honors there, talking about modeling thermal comfort, incorporating outdoor weather conditions, and sizing loads according to ASHRAE 55 and kind of the health aspect of that in the modern environment. That's enough intro from me. I'll go ahead and let Dylan get started. For people online, we have you muted, but you can type questions and I can raise them at the end to Dylan. But in the meantime, Dylan, take it away. Thanks.
Thank you, Damon. So the Integrated Design Lab, as I'm sure you're all familiar with, we focus on the 2030 challenge and net building zero design, as well as occupant comfort. Currently, we're 5 people right now. The latest add-on is Lindsay Watkins, new research graduate student. We have a program called Foundational Services. You probably know it as Technical Design Assistance. It's sponsored by Idaho Power, who also sponsors BSUG. There's 3 levels to it, from phase 1 to phase 3. Phase 1 is anything from calling myself or Damon on the phone or shooting us an email about a basic question you have about an efficiency measure, type of equipment, a standard in ASHRAE or IECC, etc. To phase 3 being scope of work, cost share agreement, as well as detailed design assistance, in-depth review, modeling, and reporting, step-by-step, cost evaluation, and return on investments, etc. We have the building metrics labeling tool, which is a free tool online. You just need to have an account with us to access it. What it does is it lets you input your utility data for your building. It'll give you an EUI. You can link it to your Energy Star score. You can also input your area to get a walkability score. You can input some building data in order to get daylight performance. And all of these are optional, so you can only have one or you can have all of them. So BSUG, we're here today. Damon talked about that a little bit. I think it's on November 11th, but we'll double check that for you. But be sure to turn out to that one. We'll be in our new place at the Water Center. We'll give you a tour of the new space as well after the presentation. So the tool and library is being rebranded as the Energy Resource Library for next year. It's what and one of the things I'm working on this year, and I've kind of put together, you may have saw them out there, are the or resource loan kits. And so what that is, we have 4 of them currently available straight out of the library. One deals with lighting analysis, another deals with rooftop HVAC monitoring, another deals with boiler efficiency, and the last one deals with indoor environmental quality. And the 5th one we have, which is not from us, it's from Green Path Solutions, is we purchased the building sensor suitcase. If you saw earlier presentation of that on BSUG, as well as last year he presented on it as well. So if you're interested in using any of those kits or the sensor suitcase, come talk to me afterwards. We have the Commercial and Industrial Energy Efficiency Program, sponsored by Idaho Power. And so we're going to get into the topic of today, which is Luminaire level lighting controls. We're going to talk about the feedback loop that goes from code, manufacturing, and industry practice. We're going to define LLLCs, compare the pros and cons, Talk about the economic incentives on why you should use them. Appropriate uses as far as building types, retrofit versus new construction. We'll talk about one case study. This one actually didn't pan out, sorry. And then we'll summarize it. So where are we going? So the purpose of building codes and standards are to set minimum practices and kind of push designers and practitioners, manufacturers towards a specific goal. 2015 for IECC for commercial buildings became effective January 2018, January 1st. And the estimated cost savings for Idaho is to be $77 million by 2030. So standards and codes impact the market by creating demand that must be met with new practices or technologies from the built environment and its practitioners. The practice of lighting design has made a resurgence in recent decades where both daylight and electric lighting is considered for space. In addition to the resurgence, there's been significant efforts to push the practice to a more scientific standard. And we see that through lighting levels, LPD values, which is lighting power density, and trying to develop a glare index. Luminaire level lighting control technology is a direct result of energy codes with stricter LBD requirements, requiring more space types to be controlled, as well as more types of controls for energy conservation. So one of the ways we do that is through CBEX, which is the Commercial Building Energy Consumption Survey. So 17% of all electricity consumed in the US is for commercial buildings, and it's to do with lighting. The biggest culprits are who you would think, commercial office buildings over 50,000 square feet. They've done a really good job bringing down that to 10% from 21%. Overall, though, we've had a decrease from 38% to 17% between 2003 and 2012. Now, keep in mind that the 2012 CBEX was when we first started tracking control strategies, such as daylight harvesting. And the next CBEX that's coming up is going to be the first one to track LEDs. So we haven't actually been tracking those yet. So we should hopefully see a further reduction in lighting and an increase in control strategy uses from the market. But so speaking of IECC, here are the basic standards and requirements as far as lighting goes. I'm going to focus on daylight zone control and interior lighting power. And so, forewarning, the trail that we choose is not always the right one. Sometimes we got to go back, take a detour, do some things differently. So this is what the daylight zone control section looks like for the 2012 version. You can see that daylight zone is defined, but not to exceed 25,000 square feet. And if you read through all of it, it doesn't actually tell you how to define the boundaries of a daylight zone. So it's a problem there. Define skylights, but only if they're 15 feet from the perimeter and they need to be controlled separately. There's one exception for the space type. And it says that daylight controls need to have continuous or step dimming in response to available daylight. So daylight harvesting is defined, but it's in the daylight zone control section. So here's the change. Anything in green was added, anything in red was subtracted, white stayed the same. So you can see we made quite a bit of changes from 2012 to 2015. For example, we actually defined different types of daylight zones. So we have the side-lit zone. So that's just your typical windows in the wall. We also now have the top light zone, which deals with skylights. Clear stories and other types of daylighting are still kind of left out in the wind at this point. There's 4 exceptions now. Deal with healthcare, dwelling sleeping units, specific application control, as well as exceptions for group type occupancies, whether they can be exempt from daylight harvesting. We retracted the actual size of the daylight zone. We're saying it can be as big as you want, just because we actually defined the subtypes of it. So now there's no, really, the chances of it increasing exponentially and getting out of control are mute now at this point. So 2018, we kind of liked a lot of the feedback that we got from it, so we kept a lot of it. Some things were changed still though, like dwelling and sleeping units got axed, and so now it's just specific application control, so you have to specifically apply that space. This daylighting controls that will respond to available, that will dim in response to daylight available in the space, got axed because it gets its own section now, which it should. And then we have daylights will automatically be turned off when daylight is present and satisfies the lighting need. So that's the section. So which covers it. So now we're going to get into kind of the evolution of LPD and kind of how that changes and evolves. So you see the majority of the chart is red. So whenever you see red, it's a decrease from the previous year, and green is either an increase or it stayed the same. So you can see we're continually reducing and enforcing stricter standards into the industry across all spectrums of building types. Getting into the nitty-gritty though, looking at library and retail facilities, we'll see that the stacks got an actual increase and then they got gutted. And then you see the reading area actually slowly declines. And apparently in 2015, all libraries no longer have card filing or cataloging spaces because they got rolled into the reading area. I don't know why, I don't think that's the case, but the code just simplifies as it goes. Same thing with retail areas, sales areas got rolled into the mall concourse. We've seen a continual reduction in that. And so some of the lighting and control strategies that we see implemented from these standards and increased restrictions and efficiency standards are occupancy sensors, exactly as it sounds. Lights trip a sensor when someone enters a room, and it will either dim or turn off when the last reading is detected. Scheduling, just following a basic scheduling. So like between 6:30 and 7:30, all the lights turn off because we know it's unoccupied, no one's working. And then later on around 8:30, the lights will gradually turn on because the cleaning staff, janitorial, other things are coming in to do it, and then it'll turn off again. Multi-level lighting, a multi-level lighting or dimming. So that's just having controlled devices that allow response to daylight harvesting, but also occupant control if they want to override it. Building automation system, allowing a BAS to control the mechanical, electrical, and plumbing systems in the building. Daylight harvesting, as I talked about. Demand response lighting, so reduces lighting by dimming or turning off lights at times of peak electricity pricing. You'll typically only see that in manufacturing and warehouses. Plug load control, devices that turn off wall plugs and lights when a person leaves a room or space. They also can follow a schedule. So, and here's kind of what CBEX tracks, although you see a lot of those up there. You'll notice that the large office buildings, you see a steep fall off when we get to daylight harvesting. And the reason for that is when they're upgrading their lighting systems to LED, newer standards of efficiency, it's really hard to sell daylight harvesting in a building that wasn't designed to use daylight. And two, they're only going to see about 1 to 6% increase in savings based off of the anywhere from 35 to 65% of upgrading to an LED technology. So it's kind of washed out by upgrading this technology. So what are LLLCs? Well, they have the capacity to have a network occupancy sensor and ambient light sensor installed for each luminaire and directly integrated or embedded into the luminaire fixture itself. In addition to those required integrated components, LLC systems must have control persistence capability. To demonstrate commercial availability of the integrated component options, at least one family luminaire kit with integrated control must be verified by DLC, and that's the Direct Lighting Consortium. It's part of IES, the Illuminating Engineering Society. So here's kind of what LLC looks like in manufacturing idea, and then here's kind of what it looks like actually in practice. So IECC actually has a definition for LLLCs in which luminaires feature an embedded intelligence, occupancy and light sensors, wireless networking capability, and where required local override switching capacity. The code requires the luminaire to be independently capable of occupancy sensing, dimming, to maintain a desired light level, including configurability to dim, set points for stepping, if necessary, timeouts, sensor sensitivity, and wireless zoning. So here's kind of the 4 basic components that you need to have a light fixture be qualified as LLC. So they have to have sensors and controls within the individual fixture that can be controlled remotely or on a case-by-case basis. Sensors for each fixture need to include occupancy, daylight, temperature, and receive or broadcast signals. So those are the 4 basic ones you're going to see. It's not limited to those, though. Each fixture then has the potential to become a semi-autonomous zone that is capable of responding to small changes underneath each fixture. Fixtures can then communicate with other fixtures using wireless, infrared signals, or a network to share data. Some LLCs can be connected by gateway transfer, so that way you can actually compile the data and actually run algorithms and see trends that are happening within the building. So here's kind of what the people that advocate LLCs kind of sell it as, is, you know, kind of a one-stop shop where everything's kind of just shoved into it. In reality, you do have to think about where those sensors are placed, how they're going to activate, as well as, you know, giving a port to upgrade. So whether you want to download or say a light fixture is not working properly, you need a way for IT or maintenance to kind of plug in and have the fixture diagnose itself and tell it what's wrong with it. And so then actually placing the sensors on the fixture, it's actually relevant where you place them, whether it's in the corners or on the rear, and the orientation that the light is installed will affect the orientation of the data that you get. So for example, if you had a row of lights and all of them are installed on this side, and then you have 2 or 3 that are installed on the opposite side, that's something you're going to have to account for when you're collecting the data and processing it, because the distance is separate. So there's 2 pathways, the standard and the advanced. The standard, so this is required by DLC to be considered LLLC. You need occupancy sensing, daylight harvesting, continuous dimming, high-end trim or task tuning, and persistence control. More advanced systems will allow for asset tracking. So if you're in a warehouse and you have certain equipment tagged with an RFID tag, it can then transmit a signal, or the light can broadcast a signal that it will then receive and ping back. And you can have an app on your phone or whatever device, tablet that you're using, will actually tell you where the device is located in your warehouse. So that's one use for it. Optimize space usage, so you can tell if a conference room is occupied or not, because your building control system or BAS will tell you, hey, we're cooling 3 of the conference rooms right now, but only 1's occupied. So the system can then recommend taking off 2 of those cooling loads. Building integration is kind of what I just described. It can integrate into HVAC, CO2, and security. The security is a little more tricky, just because it, in my opinion, it creates more vulnerabilities than actually accessibility and functions for it, but I'll get into that later. Demand response and plug load. So pros and cons. So we're going to talk about zone versus fixture-based control approach, cost comparison as far as commissioning fixture by fixture and installation. We'll talk about energy efficiency and building system integration. So a zone-based control type, you'll typically look like this. You have multiple different types of zones. There's one controller. It's hooked up to a relay. Each light is assigned a team, and they play for that team. But with most sensors, it commonly translates to a 30 to 50 foot diameter, circle diameter. So that's about 2,000 square feet of coverage. The typical office cubicle, 10 foot by 10 foot, translates to roughly 100 square feet per employee. So with that math, you basically have a chance of 20 different people to trip each sensor that's in the space. And so if a space only has a single occupancy sensor, then all the fixtures will respond to the single input, regardless of the occupancy levels. The fixture-based approach kind of takes daylight design, an old school method, and kind of updates it. So each fixture becomes a semi-autonomous zone capable of responding to small changes in the area under the fixture. Each onboard occupancy sensor can be small enough, and then you can actually, there's actually 2 types of wide and narrow field of view for the occupancy sensors. So it has a higher chance of only reacting to the movement more in its vicinity that it's actually being applicable to. So what that means is that if you have increased granularity, you get increased savings. So, and a study done at the Phil Burton Federal Building in San Francisco found that office workers were only there for less than 3 hours of their day. So if you can capture that savings of when a person's not at their desk, then that can add up over time, especially if it's a huge office building. So kind of here's what that looks like. So the zoning area base can be kind of thought of as 72 dpi. So you have an open office space. It has, say, 4 temperature sensors for your smart thermostat on the wall. So it has 4 control points of data that it's reading from and that it can respond to. Whereas if you have the fixture-based approach, say you have 30 lights in that open office, each one has a temperature sensor. There's now 30 end nodes that smart thermostat can then reference and use as a guide to figure out what it should do as far as heating and cooling loads throughout the day. So you get a finer picture of, think of it as 300 dpi. So that's the difference between it. I personally advocate for kind of a hybrid because you don't need 30 temperature sensors. I mean, they're great, but you don't need that many. So you probably get away with 10 to 15, and that will give you enough data endpoints and nodes that you could have a finer degree of control, but it's not overboard. So zone motion sensors reduce energy in open offices only 10% of the time compared with manual switches, whereas the fixture-based approach, a number of studies have found that Luminaire integrated controls reduce energy on an average of 47%. So that's just capturing all the times you're not at your desk, you're at a meeting, you take the day off, you walk by a thing and the light trips the sensor and all the lights come on. So that it's taking into that account, and that's the savings you're kind of racking up. So the main issue with zoning based approach is that even if one occupant is present in the area, then all the lights are turned on. So let's just kind of look at what that would look like. So here's kind of an open office floor plan. We got cubicles, 6 of them on the north side, south side. We got a hallway and then 2 open work areas. Okay? So this is typically what it looks like, full on, 100%. What Luminaire level lighting control says, these don't need to be on, so we're not going to keep them on. However, if you were sitting in that cubicle, something would seem wrong as you're sitting in a situation because half the floor area is dark. So then we can override, this is where we can color outside the lines of what the manufacturer recommends for the product. And we can say, instead of, because we haven't seen any occupancy, no one's walked down the hallway in a while, we're actually going to dim those to 40% of full instead of going off. So it's a little more welcoming. We can also override, because I always said it could be a case by case, or we can actually apply the zoning based method on top of that. So we can say, you guys are going to operate individually, but in certain instances, you're going to play for the blue team. And these 4 guys are going to play for the green team. So let's say these 4 people have a meeting in the blue open work area. So they're going to get up, their lights are going to turn off after the last occupancy measure mark. The hallway lights are going to go on to full since now they've detected movement. And then these guys are going to come on to full because they've detected movement, and that's what they're programmed to do. And so afterwards, these hallway lights are going to dim and go back to their regular programming. But we can also go even further depending on the manufacturer and what features you purchase from the manufacturer. You can tell this row of lights, on top of addition to playing for individually the blue team and the green team, you're also an honorary red team member, where this is going to do daylight harvesting. So it knows that this this area is occupied and should be full on. But because it's reading illumination level from, let's just pretend there's windows here, these 2 lights will then dim while these ones remain on. Or if we increase that area, then these guys would also dim, and they can dim at different percentages. So this one's dimming to 20%, this one could dim to 60%. So, and here's kind of what that could look like overall if we gave everyone the ability to control their lights, which we do have the power to do with LLLCs. Because as I said, they can connect and talk to each other over network. That network can be accessed by us via this thing, the computer we carry around in our pocket. So you can imagine light switches actually going away and you having your own personal light switch, your light switch app. And so what that means is that Tom and Jim can have theirs on 100%, but Susie and Drew, who like working in a cave, can have their lights on at 10%. Now that's good for occupant case-by-case basis, but overall, walking through that space, you're gonna have some eye strain and some contrast, especially if we get some serious changes from the hallways 100%, this is at 10%, 10%, it's gonna light to dark, light to dark. So that's a problem that can happen. So it's kind of need to have a median average or an agreement by all occupants on the floor on how lights are gonna be programmed, and you have a way to do that. So are we there yet? So selecting LLC products and setting for the maximum energy savings has the potential to adversely impact occupant satisfaction. So at the lab, we say energy efficiency, but not at the cost of occupant comfort. And so the energy savings that we're trying to capture is in this green area. And so basically, this basically follows the standard control systems, but LLCs, what they do is they take it to the extreme, and we can capture each and every one of those. Whereas if the standard control system would be, okay, it's dim, we're gonna keep it like that, less occupancy, okay, now we're gonna drop off. Whereas this says, the lights are gonna perform as they will, there's obviously less occupancy during this time, there's more, we're gonna keep up, there's some daylight, et cetera. It follows each of there's more data points plotted on the graph. So we can capture more energy savings. So what are those parameters that I mentioned that affect those savings? Well, whether you have a narrow or wide field view for your occupancy sensor, the time delay after last occupancy, whether that's 30 seconds, 5 minutes, half an hour, 2 hours, that affects it. Grouping size, are you gonna let each fixture, be on its own team, or are you gonna tell them they're gonna have to play in teams of 4, 8, 16, etc. And whether you are dimming to full off or you're dimming to a certain percentage. So the last occupancy, motion sensors. The wider the angle covered in the motion sensor, the lower the expected energy savings, because more motion events will trigger the luminaire to turn on when it's not necessary, i.e. someone just walking by a cubicle, sensor picks them up, it turns on. So if you narrow that field of view to be within the cubicle or the workspace area, then people walking by won't trip it as often. Last occupancy, so delay times guard against false negatives in motion sensors. So say you've just been sitting at your desk for a while. You've just been reading, watching a movie, doing something like that. That's kind of what the delay times are for. So you don't get annoyed that the light keeps turning off while you're still in the room. So the longer delay time, the greater chance the occupant will make sufficiency larger motion before the light is turned off, thereby reducing the chance of annoying the occupant. However, when the monitor area is unoccupied, the delay time results in wasted light. So it's kind of a fine balance, and depends on what the space is being used for. Full off or dimming. So when no motion is detected under the luminaire can dim to a lower level rather than turn completely off. Pretty obvious though, that's still consuming electricity, so you're wasting energy. Grouping luminaires. So if you can perform mesh networks, and they can be programmed into groups, so that if motion is detected by one luminaire, all the other ones turn on. You can also do that in specific sequences. So say you're in a warehouse, driving your forklift, you turn down the row, the first light picks you up. Well, it's going to send a signal to the next three that the next one should go to 80%, the one after that to 60, the one after that to 40, and it's just going to track you. And as you move through that hallway or that corridor, the light behind you is going to dim and then turn off as you continue down the space. Some people that might freak out. Me, I think that's pretty cool. But so it's just a matter of getting the occupants familiar with the new technology and comfortable using it, and is doing what it's intended. But a lot of these you're probably going to see occupant pushback, in my opinion. So how actually impactful are there? So the difference between a delay time of 5 minutes versus 20 minutes reduces energy use by 21%. So pretty significant. Leaving a luminaire ungrouped will reduce 29% compared to grouping them in groups of 8. So having the flexibility of a case-by-case basis increases your savings. The narrow field of view for a sensor versus the wide will reduce energy by 18%. Then turning off luminaires during vacancy will reduce energy up to 14% compared to dimming the lights to 20% when vacancy is not detected anymore. So here's kind of what that looks like. So we have the narrow field versus the wide field, the base case use. So if we're doing 1 minute, this is the difference between it. So 35 to 45, 10% difference. All the way up to here, if we add to 20-minute delay, we're going from 35 to about 52% increase in energy use. And that's just with the narrow. The wide field view is much greater. We go from about 45 to 60%. And so here's kind of what that looks like comparing group sizes. So if we do case-by-case basis, we're going to have a 51% energy consumption for the narrow versus 60% for the wide. And so for the narrow, it increases from 51 all the way up to about 73% if we're grouping it in groups of 8. So we see also a significant jump, but you see that as you get into the larger groups, the margin of difference between wide and narrow tends to become negligible. So at that point, if you know you're going to have large grouping sizes, you can then basically save money and just go with the standard wide field view rather than specifying the narrow field view from the manufacturer. So delay times. So if we're delaying 1 minute versus, this deals with delay time, but now we're turning them all off versus dimming to 20%. So delay time of 1 minute consumes about 35%. If we turn it off versus dimming to 20, it consumes about 45%. So the turning it completely off jumps from 35% all the way to about 52% if we waited 20 minutes. And that's while we're turning it off. If we leave the light on and dim it to only 20% of the value, it increases from 45 to about 61%. And so here's kind of what it looks like as far as just delay time for field of view, narrow versus wide, the wide being blue, or orange being narrow, and then comparing it against some other control strategy types, against space types as well. So we got break room, conference room, private office, etc., and you can kind of see where that falls. So it's pretty efficient, and it's kind of applicable to multiple space types. So here's a cost comparison and economic incentive of what that looks like. The energy cost savings range from $6.20 for an ungrouped wide view, wide field of view sensor with a 20-minute delay to saving $9.10 for an ungrouped narrow field of view with a 5-minute delay. Installing an LLC for this study, when they were installing LLCs, LED troffers, it was approximately $17, and they estimated the payback to be 1.9 to 2.7 years. So here's kind of what that looks like broken down on a case-by-case basis. So the base use cost is going to be that. If you choose a wide field of view versus narrow, that's the difference in your savings. You can see that once you start getting into all of them, it starts to adversely affect the costs. So you can actually pay more while still saving versus some strategies. And again, it's, yeah.
Sorry, the cost on the right, the balls on the right is cost or
Cost.
equipment?
Yes. And then, so that's just equipment cost, and then this is actual usage and how it's affecting that.
And then on the left, where is this data from?
It's from a, I did not put it in my notes. It's from a study. I can send you the white paper. Okay. But yeah, so we're going to get a little more into the cost, rate of return, energy efficiency, as well as if Idaho Power has any incentives for these. So here's kind of how that study broke down. The average power demand was 37 watts per fixture. The base case for time use was 15.55 hours. That was equivalent to be 1 business day. And per year was they said there was 261 business days they were considering in the year. The base case energy use was 150 kilowatt hours per year per troffer. US commercial end users, and they actually also did Canada as well in this study. Here's, like I said, $17 was the cost when they did this study for fixture installation, and the Idaho Power incentive is 22 cents per kilowatt hour saved. So here's what that looks like. I went and did my own math and applied, because I didn't actually agree with his in the payback year. His math seemed a little off to me. I'm thinking maybe he was doing the Canadian and not the US, so I did the US version. So here's the cost, and this slide is for field of view only, comparing wide and narrow. And then we're going to stick to a time delay of 5 minutes throughout, and we're going to stick to a grouping of 8, and then we're going to compare dimming to 20% versus full off. So here's kind of a cost breakdown, what that would look like. Kilowatt hours per year, how that affects it as you go. And then translating that into the actual, so these are his numbers, and then these are my numbers based off of doing the kilowatt hours per year. So I'll let you decide who's right, who's wrong. But so I estimate it to be far less, and you're requiring a greater, longer rate of return and payback. So his was 1.9 to 2.7 years. The way I calculated it's 9.1 to 10.9 years. So significantly increasing it. So it really does depend on what settings you do, and how big of a scale the project is, if it's worth it. So now we're going to look at it again. The other way he did it was a 15-minute delay, grouping of 4, and dimming 20% to full off. So again, these are his numbers, and then these are mine. So estimate if you change the savings a little bit, you cut the group in half, and you reduce the time delay by 5 minutes, you see about $3 increase right off the bat, just by doing that. And so then that brings the rate of return to 4.38 to basically an average of 4 years. So having those settings and then having them multiply by each fixture on a large scale adds up really quickly, but it can add up for you or against you. Here's kind of, I guess, a better visual of hopefully what that looks like, showing it. So the blue is the wide kilowatt hours per year, and narrow is kilowatt, or the orange is the narrow kilowatt hours per year. So the base use being 150, the field of view, so if you go wide, drops down to 90 versus 78 for narrow. Decreases a little bit for the time delay for each one. Then we see an increase because of the grouping, and then we see again an increase because we're dimming to 20%, not full off. Here's the cost difference in the savings, so you kind of see the rises and falls for depending on the parameter and how, what level you set it to. Then here's kind of the payback in years. So basically it depends on what parameters you want, what the space type is being used for, and when your client or building owner wants that rate of return. So cost considerations. Fixtures can cost more, but the cost of installation should make up for that. Less labor to install the sensors, less wiring between fixtures, less time for startup and programming, because if it's a network gateway LLLC, you can do it remotely. You can just tell the fixture, give it its program, download it, update it, etc. Check with your utility provider to see if incentives are available. I currently don't know any Idaho Power incentives specifically for Luminaire level lighting controls. But if you would like to see them, ask them for it.
Well, we have a network controller.
Ah.
Give to satisfy all the network lighting.
Oh, okay. So there's one potential incentive for you to apply for. So here's kind of what that looks like. Some other cities and areas have the incentive. Seattle City Light is $40 to $100 per fixture. The reason for that is because the price tag per fixture jumps like a considerable amount from just a base level fixture because of what you're adding to it and the capacity for it. So that's why a lot of them will target the per fixture costs. So it kind of reduces that sticker shock for the owner. Currently, Idaho Power has 22 cents per kilowatt hour saved. The national, though, it's Still not recognized nationally as much as the technology manufacturers would like it to, but there are some areas that that does it. For example, Wisconsin, as well as National Grid, they'll give you $25 per fixture. So kind of here's what that payback looks like with the incentive included for the kilowatt hours that you'll be saving. And so the rate of return then comes back into line with the gentleman who originally did the study, his agreement. So I'm thinking maybe he counted some incentives or utility kickbacks that he was getting and just did not disclose that in his numbers. But as soon as I calculated it with the incentives, everything kind of started to fall back into line with his numbers. So I'm thinking that's what it was, but I don't know for sure. So appropriate uses. Building types, so offices with relatively low or high variable occupancy rates. Schools with respect to occupancy and space types, so gyms, cafeterias, hallways, restrooms, offices, admin, library, and classrooms when applicable. Depends on the size of the classroom, the size of the library. Smaller ones, you probably are not going to get the bang for your buck that you're going to want. Hospitals with respect to occupancy and space type, so you want to do office admin areas, patient recovery rooms, lobby, and waiting areas. You don't want to install these in an operating room and things like that, so don't go overboard. Just keep it restricted for that space type specifically. Something to note is a study done found that nurses in hospitals, I believe it was 2.25 hours out of their working day is spent just looking for things. They don't know where it is or where it went. So if your light fixture throughout the entire buildings have sensors that can broadcast and receive signals, you stick an RFID sticker on a wheelchair, a box, or something that has equipment in it, the nurse can pull out their phone, their app, wayfind, and locate that much more efficiently. So that's one of the better uses for it in the hospitals. New construction versus retrofits. New constructions would be most ideal for LLCs because the building and its systems can be designed to allow for integration of LLCs and have the network capacity and things like that for it to scale even further. Retrofits' main benefits from LLCs is their programming flexibility and that the overall lifespan of a building or that space can be much more adaptable because you just need to reprogram the lights. I think the next slide. No, not that one. And you can implement additional lighting control strategies, and you can also remove them fairly easily without having to uninstall the hardware. You just reprogram it. So integrating building systems. So to do that, first thing you need is to be networked. So you need to have that capacity for your light. The typical ways you're going to do that is through the occupancy and vacancy sensor, temperature sensor, and security sensor. And so the network is to exchange information and configure the device on an individual level. Occupancy is to regulate lighting and other equipment based on detection of people in the space. Temperature is to assist with regulated heating and cooling loads, specific types or tasks. And security is to prevent unauthorized access to the system and any other connected system. So maximum flexibility is kind of the idea or the ultimate goal of LLCs. So you want granularity of control down to the individual fixture, future proofing, so adaptable space usage, and have the potential to eventually tap into IoT, which is the Internet of Things. So for those of you unfamiliar, the Internet of Things kind of, encompasses a lot of things. So here's kind of a diagram kind of showing the diversity of the industry that it's applicable to. So for us, the Internet of Things, these things for our intended purposes become thermostats, occupancy sensors, photo cells, mobile devices. A lot of things I've been talking about. And plug loads connected to these things create a network which then creates a sensor network that can be used to solve energy management in buildings and the basis for future planning and decision making. And so here's kind of what we're interested in having those be for smart lighting, or eventually what we hope to call the Internet of Lighting. Obtaining information, so devices and IP end nodes, reliable delivery, so connectivity and control strategies, and processing data for analysis, algorithms, and feedback loop. And so here's kind of a broad kind of way to categorize those things as we as practitioners of the built environment think about it, different from IT or network people. And so here's kind of the goal, or just kind of I guess the horse race on where we are as far as technology's going. We have the micro smart grids, which encompasses the built environment in the building. We have the Internet of Lighting that's upcoming, and it hopes to do user, workstation, room, floor, and building. Micro smart grids hope to go from the room to the workstation to the user. LLCs are kind of in the middle, where they can do the building, floor, room, and workstation area. They're working on the user part of it, but in my opinion, when they get to there, they're basically going to be absorbed into IOL. So occupant comfort and productivity, just lighting and color temperatures for occupant comfort, optimize productivity through task tuning, and can provide demand-driven heating and cooling. So LLCs in hospitals, as I talked about earlier, they can create a more healing environment with higher aspects of lighting that adapt to the patient needs. So the light switch can literally be in their hand and they can control it. Reduce unnecessary purchases and wasted labor by enabling smart asset tracking for medical equipment. As I talked about earlier, nurses waste about an average 2.25 of their day looking for things. You can increase patient satisfaction rate and staff happiness and productivity by optimizing light temperatures and intensity, and also increases network connectivity for them as well. In schools, enhanced learning conditions and lighting that improves visibility and adapts to students' needs, easily create ideal lighting environments, pretty flexible, increase safety and security and efficiency standards. So say, fire alarms pull in school, all the lights then go off, and only the lights, and then lights would come on that would navigate you to the nearest exit. So you could have that be a thing. Also, the fire department or emergency EMS services could have an application that links up to the building system that tells them who's occupied or what spaces have occupied people in that room, or where are they located in the building. So there's future applications for it long term. Office buildings, like I said, high variability changeover, and it can basically increase employee satisfaction rate and productivity. So the other thing we can do, with addition to having it be a light switch on our phone, is we can have feedback. So you can take a survey and the light will literally tell you, you can say, I don't like this. And so the light's gonna be like, okay, I'm gonna change it a little bit. And you're like, is it good, better, best, worse? What's the scenario? And you basically take that survey and you can tune it to the occupant. And then, so LLLCs kind of networking to the IOL is kind of be the final building block we need to complete the glare index for determining what lighting conditions make a person uncomfortable or not, and where you fall on that index, because it's going to greatly increase the end nodes and the data that we can collect and get accurate feedback in real time as well. So real quick, the case study I have for you guys is the GEM building. It's 24,000 square foot 1970 office building. Was renovated to be artist studios, kind of private offices, as well as gallery spaces and display spaces. So it had T12 linear fluorescent lighting, and they switched to a smart panel series, which qualified for LLLCs. Here's kind of what that looks like. Here's a entrance to a gallery space, and here's a private studio. And so here's the lighting specs comparing the two. You'll notice that the input power is 160 watts compared to just 35 watts. So again, it was really hard to convince the client building owner that to go with this product, because they were seeing such a significant decrease just from upgrading to an LED from fluorescent. But we were able to convince them to do that, and we were able to reduce the overall fixture count. Oh, it's in the next slide, sorry. I was looking for something else. The original layout had 382 fixtures, 2x4 with 440 watt T12 linear fluorescents. The over illumination was confirmed during a site visit with light meter. You can kind of tell just by walking into some of the spaces, it was pretty bad. The average foot candle was 151, which is about 4 times the recommended value of 35 to 45. So here's kind of a breakdown of the energy use, the yellow being the lighting, and this being kilowatt hours per year. And so here's we downgraded for the new fixture, we were able to downgrade to 248 fixtures, which was a reduction of 134 and 125 watts per fixture. So pretty big savings, 85.7% reduction from the original LPD of 2.8. In addition, they dropped the interior wall, so they no longer extended to the ceiling, and they got rid of the ceiling. So more ambient light could get into the perimeter spaces. And so in yellow, this is kilowatt hours per year. You can see the reduction of it. So going from around 15, 16,000 average a month to just to 2,300, 2,200. So as energy codes and energy efficiency goals become more demanding, LLCs create the flexibility for space utilization and improving occupant comfort while providing controls and reducing demand for energy demand for lighting. Allows building owners and facility managers to collect more data to inform programming choices such as scheduling and occupancy. You can adjust the output of individual lights or a group to set a level. Building or spaces within a building may need to be repurposed from the original design intent, as was this building. It was all closed, private offices, majority of the spaces, repurposed it, and the owner of the building can continue to repurpose it now that they have that lighting grid established. Some of the cons. Occupants may be unfamiliar with the lighting design intent or operation. For example, occupants may report that light in a space will not turn on upon entering a room, assuming them to be malfunctioning. So one of the things I disagreed with the owner about was taking out the light switches. I really wish she left them in. So one guy, I went back several times to help them reprogram and create a startup guide on what to do if something goes wrong with the lights. And one guy just said, "Give me my damn light switch back." So it takes some getting used to of, when you walk into a space, you'll automatically go flip the light switch on. So if it comes on automatically, it kind of throws you for a loop, especially when you're expecting when you leave to flip off the light switch, and you're like, you have to trust that it's going to do what it does and it's going to turn off or dim as it's supposed to. So one of the things we ran into was programming and user interface. A lot of people didn't understand that, which is kind of why I created the startup how-to quick guide on how to program it, what buttons to push, in what sequence, and what they were doing and why. So explaining that to building occupants should be emphasized heavily when you're using this technology because it is new. Or you could just keep the light switches. That would also solve the problem as well. But you would find that the occupants are overriding the technology and the control strategies more frequently. So it's a balance and trade-off on where you want to use it and how often. So to summarize, LLCs incorporate sensors into each fixture, such as occupancy, daylight, temperature, or receive and broadcast signals, which allows each fixture to become a semi-autonomous zone that is capable of responding to small changes in the area under the fixture. It's basically meant to be a turnkey solution to meet demands of the code now and in the future. So out of the box, plug it, turn the key, you're good to go. Reduces labor, installation, maintenance, and cost of lighting systems. Right now, it's just reducing. It's not really disrupting the industry quite a bit. But once PoE, power over Ethernet, takes off a little bit more and connects with IOL, Internet of Lighting, there's going to be a huge disruption in this lighting chain. It says high potential, as I said, for bringing IOL to North American markets. Currently, China and Europe are the big players for IOL that are developing right now. High potential for being a stepping stone to utilizing smart grids in buildings as well as integrated building systems. So, some cities are starting to get onto the grid, smart grid, monitoring their data, seeing trends, trying to anticipate things. We can take that a step further into the building if we do this. Selecting LLC products and settings for maximum energy savings has the potential to adversely impact occupant satisfaction. So please remember energy efficiency, but not at the cost of occupant satisfaction. Here are my works cited. I believe, no, this one, I believe it's this one. Is that study I was referencing, Shelley, that you were asking about? I believe it's this one. So any questions? Sorry, I believe I'm a little over time, or no, hey, I'm actually under time, all right. Yes?
Dylan, no doubt there's some pretty great energy efficiency potential applications. Anyway, some pretty great energy efficiency applications with the LLLC stuff.
Yeah, I really don't agree with the acronym they chose.
Yeah.
It's a bit confusing.
The COM applications though are really interesting to me, and maybe even more than the energy efficiency part of this. And so like lots of us wear little badges around. That'd be really easy to have that putting off an RFID where it would know. I mean, the lights would essentially know where everybody's at. You know, in the building. Have you come across any examples of that implementation yet?
No, not yet. And for that, for another presentation I have on the future lighting controls, there's a slide in there that I posed the question, do you want to know how many people are in the conference room or who's in the conference room? To me, the question you should be asking is the first one, not the second one. The second one kind of is an invasion of privacy. And that's really concerning to me because we don't exactly have the best data privacy laws in America right now. And security is going to be a huge issue with Luminaire level lighting controls as they continue to progress and they get that network and comm communication. So another example I have in that slideshow is that a casino got hacked, their high roller database got hacked because hackers used the smart pump from the fish tank in the lobby to piggyback into the Wi-Fi main database system. So now if you have all your lights being smart to receive and connect to the network, you have that many more access control points you have to worry about. So then you have to talk about communication standard and encryption and security. And we all know everyone is great at updating to the latest security standards. So that, to me, that's a huge problem. Any other questions?
Is 90.1 Appendix G or any of the other energy modeling standards or guidelines recognizing this in sort of a deemed way as saying you do Luminaire level controls, we'll give you, say, 20% reduction on your LPD, give you credit for that?
Not to my knowledge. Like IECC, they just barely mention it. They have like what I put up there was what they had. It's just one small paragraph. They just acknowledge its existence because basically what it's heading to is so talk about PoE for a little bit, power over Ethernet. Basically, that code authority standards has been forced to accept PoE because LEDs reduce the lighting load by such a significant factor that you can then power that through an Ethernet cord. And so they're basically saying, wait a minute, no, a light fixture can't send and receive data. That's not what it is. It's a light fixture. It provides light. And now we're like, no, it can do this as well now. So there's rapidly changing and trying to define it right now is pretty hard because it's advancing on 3 separate fronts where you have the manufacturers, they've come up with LLCs. You have datacom, telecom networks companies that are investing in IOL, and then you have up and coming manufacturers that are investing in PoE. Because if you notice, like our phones, I'm sure a lot of your phones, doesn't have a power port anymore. It just has an Ethernet jack, and that does everything for it. So basically, you can think of that as eventually coming to lights too. Any other questions? Chris again?
Another really cool application you mentioned, I thought, was related to communications, was like if there's an emergency, they could light to egress, all the other pictures go off, they just show the path there. And I know I've seen some LED fixtures that can change colors, any color you want, off an app, off your phone. Yeah. I'm curious if you have any idea of the premium in cost between like one of these LLLCs that can change color versus not.
No, I don't have that. I just basically have the cost comparison between, the standard fixture using the zone-based approach where the sensors are separated from it versus, the increase of costs through putting 5 additional sensors into a light.
Where's that color changing capability goes? Any idea?
That could be
double the cost for that fixture if it's
No, I don't think it would too much. But like right now, it is a little bit of a price tag. But PoE is revolutionizing, like I mentioned earlier, it's revolutionizing LEDs because it's actually changing the fundamental architecture of the light bulb because you can take the power source out of the LED. So it's being supplied elsewhere. through the Ethernet jack. So you basically change the internal architecture of the LED. So then it could, we could like, hey, there's room for this now. So because we don't have the heat source, and the heat sink and the power is typically the biggest driver on the lifespan of LED. So now we remove that. The lifespan was already ridiculously long. How much longer can it get? So LEDs are still revolutionizing and disrupting the market today. Any other questions? Yes.
I'm an architect, and on several recent projects, I've had owners object to the presence of any lighting control panel at all. If there's our clients are typically smaller institutions.
Okay.
Don't have maintenance staff maybe at all. It's the owner himself have to learn this stuff. And so do you consider this to be a higher learning curve or equal learning curve to current lighting control systems?
So currently right now, I see it as an asset, something to assist current installers and practitioners. However, when we get a little bit further on in technology, like I talked about PoE and Internet of Lighting, that's when it starts to flip things on its head. Because so basically, if you have IOL in a building, which requires LLLCs to have that capacity to operate on IOL, you then change who maintains that. So your lighting, power, information, scheduling, and all that is going over a data SQL, things like that. Forgetting the actual technical IT architecture name for it. Server networking capacity. That's it. So you then have to design your network to take that into consideration. And so if that's being run that way, something happens with the light fixture, who do you call to fix it? Do you call maintenance and facility, or do you call IT? So now you kind of need a new person, or you need the maintenance or the IT to kind of step up their game and learn a little bit more. So it also changes us as practitioners, the way a building's designed, because when is typically that IT network and infrastructure installed in the building? It's last. But now if your lighting, your security, and a lot of these other things are going to rely on that, that changes how a building's actually put together. Because you're also if you include PoE, you're then changing how power is distributed in the building. You're going to have several areas where it's concentrated and then just dispersed, where it's not being constantly dispersed throughout the entire building. So did I answer your question? Maybe not. So currently right now with LLLCs, it's out of the box, turnkey, meant to be for, that type of person you're talking about, where it's just follow the instructions, plug it in, hit this number of sequence, and it will run for you.
And you don't have to adjust things yourself.
Mm-hmm. Nope. And then you basically pull out the app, or you go on your computer online, or you download their software and install it as an application, etc. And then you program it. It's pretty straightforward. The drop-down menus, button clicking, visuals, etc. But just as it progresses, it's going to do the opposite. It's going to eliminate the need for having a lot of those people to do it for them. And eventually, commissioning is probably going to be the most adversely affected by it, because it's going to increase the rate of efficiency at which you can commission a building. Two, you probably won't even have to actually visit on site. You could just remote into the system and look at and have it tell you what's going on. So, did that answer it better now? Okay. Question? Maybe? No? Okay. Thank you very much. We're going to